All right, here we are with another growth example. So I'm looking at my data, and it seems to me that every 2 hours, because my time is going up by 2, it looks like I'm tripling. So 450 times 3 is going to give me 1350. So I want to think of, so how did the population change? It's tripling. All right. An equation for P of t? Well, for P of t, to find my equation, I need to know my initial population. So I need to go backwards. So I'm going to divide by 3. So initial population is going to be 150 divided by 3, which is, of course, just 50. My growth factor is I'm doubling every 2 hours. Sorry, not doubling, tripling every 2 hours. So let's think about what that's going to be. So I could write my equation as initial population times tripling every 2 hours times time. But of course, I can rewrite this bit as e to the ln of 3 to the 1. Sorry. Yeah, that's correct. ln of 3 to the 1/2 all times t. So either one of those is equivalent. There's my equation for P of t. What will the population be after 1 day? Well, 1 day is 24 hours, so I want P of 24. Come to my calculator to figure that out. So I'm going to take 50 times 3 raised to the 24 times 1/2. Here's my population. Let's see what it asked for me. What will the population be after a day? It doesn't tell me to round to a nearest value. So we've got times 10 to the 7th. So about 26 million. So let's see, what did that say? 26,5,721. So 3, 6, 7. Except I had 2.65 to the 7, so I think I actually need another 0 in there. So 3, 6, 7, yes, and so my commas are in the wrong place. Hiya. 6,512 times 10 to the 7th bacteria. All right. And I can verify my other equation, see if I get the same thing. So we've got 50 times, oh, that's not what I want to do. I would like to do this one, e to the ln of 3 raised to the 1/2 times t close my parentheses times 24, and we get the exact same answer. And now I want to know, I think I did, this should be a 2-1. Okay. What will the population be after 1 day? To the nearest hour, when will the population reach the billion bacteria mark? So D, I want P of t to be greater than or equal to 1 billion. 1 billion is 1 times 10 to the 9th. So I'm just going to use my solve function. I'm going to go up sorry. First, I'm going to put in solve. I'll take my equation. I'm going to replace that 24 with a t. I want it to be equal to 1 times 10 to the 9th. I'm going to solve for t. And we get 30.6 hours. Well, if I want it to the nearest hour, I'm going to say 31 hours because at 30 hours, I haven't actually reached a billion yet. So t has to be equal to 31 hours.